Okay, guys, I want to walk you through the problem that we were working on in class and just make sure that everyone's clear on what the solution should be. When I went back to my office, I figured out what the mistake that we were making was, or at least as a class that I didn't catch. And so let me just recap what's going on here. So here's our chart, and if you look here on the chart, we've got June 21st. Okay, it's the 1403. So let's go back here. Oops, that's not what I wanted. There. Okay, so we have 14 hours. I shouldn't write it like that. And 3 minutes, and that's going to occur on June 21st. Then we also have, let's go back, our shortest day is December 21st. Okay, the shortest day is 10:14. So 10 hours, 14 minutes. Okay, so that's December 21st. Excuse me. So there's a couple things that we need to know. There's two problems in your book that actually do the same thing. So what I'm going to end up doing here is I'm going to use the sine function because that's what one of them uses. Okay, so what they ask is they ask you to come up with an equation I'll write it exactly how they've got it here. Okay, so they need you to find A, which is the amplitude, omega, phi, and this B value. So what they'll do is they'll say, okay, look, here the longest day of the year's got so many minutes, and so many hours, excuse me. So for us, that's 14 hours and 3 minutes. So it's 14.05, which I believe we came up with in class. So 14.05 hours on June 21st. And then 10 hours, 14 minutes. Gives us 10 hours and 10.23 repeating. Okay. So our amplitude, if you think about the way the curve is going to work, your initial sine function looks like this, and we want this length, which is the A value, that's the amplitude value, we want that to be half of this. So what we're going to do is we're just going to take the difference of those two values. So the 14.05, oops, 10.23 repeating gives us 3.816 repeating. That's the difference. I shouldn't write that as A. That's the difference between the values. So what we need to do is we need to take that value and divide it by 2, and that'll be the amplitude. So let's grab that thing, and let's divide that by 2. So 1.908. Okay, just like that. So now I've got my A value, so I'm creating my equation up here. I'll write it in red. And I've got 1.908 times the sine of omega x minus phi plus that B value. So the next thing we need to figure out is what is the period? Okay, so we know that we're given that the period, the length of a year, we already said was 365, and we know that that is equal to 2 pi. Oops. So let's over omega. So to solve for omega, we're just going to go ahead and solve this guy right here. So we'll get 365 omega is equal to 2 pi, or in other words, that omega value is equal to 2 pi over 365. So now I've got two of the pieces. So we're at this point right here. This is where we were in class. Okay, this here right here is where we were having the issue. So I'll circle it. This guy right here, and that's my fault. Okay, so what we were forgetting about doing, and that I should have mentioned was, remember this value right here isn't just the shift value. Okay, the shift value is by pulling out. Remember, because this impacts this guy right here. So that's going to change that value. So here's what I'm going to do. I'm going to make this actually easier than what we were discussing in class. The summer solstice is the 172nd day. So I went and made sure that that number was right. So the peak should happen at 172. So what I want to do is I want that peak to correspond with this guy in here. So here's the trick that I'm going to do. I'm going to say the following. I'm going to say that I want that inside guy 2 pi over 365. Now I'm going to put in 172 for x. So on day x, on day 172, I want that thing to be equal to, now here's what I'm going to do. So this, and there's other ways to think about this, but here's just kind of what I came up with in the office. This guy would normally, the peak of the sine curve would normally happen at pi over 2. But I want it to occur when I plug in 172. So what I want to have happen is I want this guy inside here to, when I plug in 172, I want to get this whole guy equal to pi over 2, because then it'd be like taking the sine of pi over 2, and I know the sine will be at its max at pi over 2. So when I plug in 172, I want this guy to give me the max out. So what I'm going to do is I want this thing to be equal to pi over 2. And I'm going to solve this for phi. And when I do that, that's going to give me the value, like I said, that I'm going to have to plug in right over here. So how do we do that? Let's just multiply everything by the common denominator to get rid of the fractions. It's easier that way. So let's multiply everything by 365 and by 2. So when I do that, this is going to give me 4 pi times 172 minus 720 phi is equal to 365 pi. So I multiplied, what I did here is I multiplied everything, both sides, by 720, which is the common denominator, 365 times 2. So this is everything multiplied by 720. Now I'm going to solve for phi. This way I don't have to work with fractions anymore, which I like. So 4 times 720, let me grab the calculator here. Oops. Not 720, 172. That didn't look right. Okay, it's 688. So what we've got is 688 pi's minus 720 phi is equal to 365 pi. So if I keep solving that guy, that's going to give me, I'm going to move this 720 over to the other side, so I'm going to go 688 pi minus 365 pi is equal to 720 phi. So this side over here, I believe, is going to be, well, let's just do it out so I don't make a mistake here. So that's going to be 688 minus 720. Excuse me. 688 minus 365 is 323. Pi is equal to 720 phi. So phi is equal to 323 pi over 720. So now we got this guy right here. So what do we know? We've got 1.908 times the sine of 2 pi over 365 times x. Okay, now which way are we going to shift? So what we want to do is we're going to leave this as minus. So it's going to be a shift to the right, but what we're doing is we're leaving this as minus because notice I left this thing as minus here. So my phi value is minus 323 pi. I don't know if you can see that anymore, if it's over on too far on the edge here. I'll rewrite it over 720. I'm also going to switch my page setup here real quick so I get more space on the bottom. So we can scroll down a little bit. So let me rewrite that. I've got 1.908 times the sine of 2 pi over 365 x minus 323 pi over 720 plus b. And the question is, what's b? Well, the nice part about using the sine function here is that currently sine is split real nice here. Okay, so what I'm going to do is I want to take this guy right here and I want to move everything up. How far do I want to move it up? Well, I want to move it up half the distance of my values. So let me grab my calculator here. I'm just going to pause this. Whoops, I'm just going to pause this thing for a second. Grab my calculator. Okay, so I've got that. Now what I want to here's that calculator. Okay, now actually before I do that, let me just explain something. So the deal is I want to take this thing and I need to raise the whole thing up so that its center, which is right here, is along the center of where it needs to be. And the center of where it needs to be is exactly between these two values. So all I got to do is find the value right in between here, basically average. So I'm going to take these two numbers right here on my calculator, I'm going to average them. And that'll tell me my b value. So that's 12.14. So this value here is 12.14. And this right here is our equation. Now we can check to make sure it works. Okay, we can verify that it does. I think last time we were discussing that. Let's see here. We were picking a day. It doesn't really matter which day we pick. I guess I probably could let you play around with this thing. Actually, I'm going to let you because I'm going to run out of time and I won't be able to upload this to YouTube if it goes a whole lot longer because I think I'm getting pretty close to my max time. I've only got a minute left. So, to keep this short, this is how you set this thing up. So here, this problem right here, this was the issue that we were having before. And the problem was I wasn't taking this guy into account, and I have to do that. Otherwise, the rest of our setup and everything was good. So what I've done is there are 2 homework problems on my math lab and that involve this. So I put them on the homework. I won't have this problem on the test, but I do want you to play around with it on the homework. Okay, because I think it's good for you to see and practice a little bit. So there's a lot of homework problems. I understand. I'll extend the date if it looks like we can't get it all done, but I want you guys to put in an honest effort, and I'll take a look at all that. So good luck with that, and we'll see you guys on Monday.